Good day, students. Today we're going to look at a problem in a series of hypothesis testing. So let's get right to it and decide what type of problem we got and go right through the solution. Does right or left-handedness affect how fast people type? Random samples of students from typing class are given a typing speed in WPM, words per minute. In the right-handed group of 16 students, the mean was 55.8 words per minute with a standard deviation of 5.7 words per minute. In the left-handed group of 9 students, the mean was 59 words per minute with a standard deviation of 4.3 words per minute. At a significance level of 0.10, can we conclude there is a difference between the typing speeds of left-handed or right-handed people? Alright, so we got two groups obviously, so we're dealing with two sample. Now let's see if it's a two sample T or a two sample Z test. So we have right-handed people and we have left-handed people. In our right-handed people, let's see what we know. In our right-handed group of 16 students, so N1 is equal to 16 and the mean was 55.8 words per minute, so X bar, the mean of the sample, X bar 1, sample 1, 55.8, and S, which is the standard deviation, or S sub X, whatever you want to call it, and the standard deviation is 5.7. So we know everything about the right-handed sample group. In the left-handed sample group, let's see what we have. In the left-handed group, we got 9 students, so N2 equals 9. We know the mean is 59. So X bar 2 is 59 words per minute and a standard deviation of 4.3 words per minute. So S or SX2 is 4.3. Alright, let's go through our 5 steps now that we know, got our information listed down. So the null hypothesis, okay, and alternate hypothesis. Look at the phrase, is there a difference between the typing speeds of left-handed or right-handed people? So if I look at that phrase right there, then when we talk about the difference, are they means not equal? Okay? So in this case, obviously I'm using right-handed people to be mu1, left-handed people to be mu2, and I'm saying therefore, is there a difference between them? Mu1 not equal to mu2. Alright? Let's just see if I can get rid of that. Popped up there. Good. Okay. So is mu1 not equal to mu2 and mu1 equal to mu2 for the null hypothesis? Now again, just to verify, remember the equal sign is always in the null hypothesis, which is what we have. Mu1 not equal to mu2 tells us what? When we have the alternate hypothesis we're not equal, it tells us this is a two-tailed test. And a two-tailed test means what? If it's two-tailed, the area is of course alpha over 2, isn't it? Now, next step is fairly easy, straightforward. What is alpha? Well, alpha, we don't even have to choose it, do we? Look, it's given to us. The significance level is 0.10. Now, what test do we run? Okay, now, decide what test. Do we know the standard deviation of the population? Do we know sigma, the standard deviation of the population? No, we do not know it. And for our purposes, that means a t-test, right? Because sigma is unknown. And don't forget, look, populations for both sample size, sorry, are very small, right? So this would definitely be. So sigma is unknown is all you got to say for t-test. Now some books will say if sigma is unknown, automatic t-test. Other books will say if sigma is unknown, however, if the sample sizes are greater than or equal to 30, both of them, we would opt to a z-test. As the numbers get very large, it doesn't really matter if it's a t-test or a z-test. But when sigma is unknown, the safest test to do is the t-test. Okay. Now, number 4, decision rule. Of course, with decision rule requires a little bit of work first. So step 4, we need to find the critical value of t. So we call it TCV for critical value. People often refer to this as the critical value step, right? So find the critical value, make your decision. So the critical value is going to be the inverse t of what? Now, when you're asked for inverse t, you're going to need the area and you're going to need degrees of freedom. Now, we need to talk about pooling data here. When we pool data, because you're going to be asked for that in step 5, whether you pool the data or not. Okay? When you pool data, what you're assuming is that the standard deviations of the populations are the same. And I think we can make that assumption here, because we're dealing with typing speed. Whether you're left-handed or right-handed, it shouldn't really make a difference. So we can assume here, I think fairly safely, that the standard deviations of the populations are equal. And if that's the case, it means we pool the data. And pooling the data means our degrees of freedom. All right, it's a simple formula. You add up the two sample sizes and subtract 1 from each, or subtract 2, right? So we use this formula when we pool the data. Okay, and you'll see on the calculator when we're asked to pool that data. Okay, so we got 16 plus 9, that's 25, minus 2. All right, so that's 23 for degrees of freedom. Now, over an area, of course, what is that? Well, we said already it's a two-tailed test, so the area is alpha over 2. So 0.10 divided by 2, of course, is 0.05. So we head to our calculator to get that information. Now, again, where are the critical values or t values found for distribution? Right under the over the vars button, you'll see DISTR, distribution. So hit the blue button first, second, vars, and you'll find the critical value as an inverse t. It's asking us for the area, 0.05, and the degrees of freedom, 23. So I hit enter there, and what do I get? We get a value of negative 1.714, or negative 1.71. 2 decimal places is plenty. Now, but that's only one critical value, and we said it was a two-tailed test. A two-tailed test means two critical values. So it's this one and the positive of that, right? And the positive of that is 1.71. So there's our two critical values. So you only need to run it once for a two-tailed test. Just use alpha over 2, and then the other one will be the positive of it. Okay? So here, so somewhere down here at negative 1.71, and somewhere up here symmetric to the other side, in positive 1.71. And what it's saying is this, that this area in here, okay, shade this area above, this little area here, alpha over 2, is 0.05, and that's rejecting the null hypothesis. Right? Because remember what alpha is now. Alpha is the probability of rejecting the null hypothesis, even though it may be true, right? Okay, so this is alpha over 2, 0.05. Now, so what's our decision rule? Everything is set up for you. So in other words, if the value is less than, if it's down in this region, so if it's less than negative 1.71, or it's up in this region, greater than 1.71, we're going to reject the null hypothesis. So that's our decision. And you write it just like I said. Okay? If the test value you get in step 5 is going to be less than the critical value, or greater than the other critical value, then we're going to reject, run out of room, null hypothesis. Okay? So let's run step 5 now. Let's actually go run the test and see, okay, what I have here. Number 5. Alright, so we're going to do what? We're going to stat over to tests, and we're going to run, this is a 2-sample t-test. 2-sample t-test. Okay, now, are we doing it with data, or do we have the statistics? Well, if you look down here, we have the statistics on both samples. See, we have that one, we have the sample size, the mean, the standard deviation. So we have that for both samples. So we're using the statistics. So go over to stats and hit enter to highlight stats. Notice how the window changed. Now we're down to asking us for the mean of the first group, which is 55.8 words per minute. The standard deviation of the first group, which is the right-handed group, 5.7. And the sample size, 16. Next is asked us for the mean of the second group, 59 words per minute. 4.3 is the standard deviation, and the sample size is 9. Okay, going down now, determine is it a two-tailed? It is two-tailed test, so make sure that's highlighted, which it is. And pooling the data. Now again, if you're not sure about pooling data, just ask someone, or ask your teacher about that again. But in this case, we did make the assumption that the data was pooled. Now in another alternate video, we will talk about a sample where we do not pool the data and how the problem changes slightly. Okay, so we're going to say yes to pool data. Okay, because we're assuming the standard deviations of the populations are the same. Okay, so enter for yes, and then of course calculate. Alright, so we get a t-value of negative 1.46. Now where is negative 1.46? Okay, so where is negative? So it's somewhere right here, isn't it? Now, so what region is this? So negative 1.46 is right here. This is in the do not reject or accept region. Okay, I've been using both, do not accept or do not reject, and I've also been using accept because some books use accept, some use do not reject. Technically, I suppose do not reject is the null hypothesis is safer wording because there may be a type 1 or type 2 error. Right? So now, therefore, our conclusion is accept the null hypothesis. I'll use the word accept. Now, accepting the null hypothesis, say that in words. What does that mean? Well, we're accepting what? The fact that they are equal, right? There's no difference. And, really kind of what we expected, the typing speeds not to be, right? So, no, there is no difference between the typing speeds, right? There is no difference. Okay, in the typing speeds. I'm going to run out of room here, I think. See if I can squat it in here. Typing speeds of left-handed and right-handed people. Alright, anyhow, I know that's a bit squat in there, but I think you can see that. Okay, so, and the other part is the p-value. I just want to mention that before we sign off. Look at the p-value there. Okay, let me put a circle around this. Maybe you can see that a little better. How about I do that? Okay. Alright, the p-value is 0.157. Now remember, when the p-value, when p is greater than alpha, is another test to accept the null hypothesis, which it is in this case. So 0.157 is greater than 0.10. Okay? So there's nothing in this test that tells us the typing speeds are different, right? We've concluded there is no difference between left-handed, right-handed people when it comes to typing speeds. Alright, that's it from me for now. Over and out.